So we're going to be going over simplifying square roots. So the perfect square of a number is the factor that we can multiply by itself to get that number. So again, it's going to be a factor. But you need to make sure that that factor is being multiplied by itself. And I'll give you an example right now. So if you have 16, we know that 16 is a product of 1 times 16. We also have 2 times 8. And we also have 4 times 4. So our definition tells us that it must be a factor. So the factors of 16 are 1, 16, 2, 8, and 4. So those are the factors. But the key is, it says that it's being multiplied by itself. 1 and 16 are not the same number. 2 and 8 are not the same number, but 4 times 4 are the same number. So we're looking for these factors. That is the one that is being multiplied by itself. So we're going to need those numbers to find what the square root is. So in this example, we're looking for the square root of 100. Now, in the right-hand side, you see your perfect square. So we have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So we know that 100 is a perfect square. So this makes things easier because we know that the square root of 100 is going to be the same thing as saying 10 to the second power. The square root and the exponent cancel. So they are inverse operations of each other. So our answer is going to be 10. So the square root of 100 is 10. And you don't have to write anything else down, just the number 10. All right, so we're finding the square root of 36. We have the square root and we are looking 36. Again at our perfect squares. Through our list, we know that you see that 36 is a perfect square. Once again, so that's perfect. It's a perfect square. We know that. So what we're going to do in this case is we know that 6 times 6 is 36. So we have 6 as our answer. That is our answer. We don't have to do anything else. We know that the square root of 36 is 6. If we look at the square root of 75 and we look at all our perfect squares, 75 is not in our list. So what you have to do here is split that square root into smaller numbers. We can divide 75 into smaller numbers. So to do that, we're going to write 75 and we're going to split that into 5, because any number that ends with 0 or 5 is divisible by 5. And that's going to give us 15. Now, 5 and 15 are not perfect squares either. So we need to split them again. And that's going to give us 3 and 5. Now that we have all these numbers, we can actually see a pattern. Because we know that 5 times 5 times 3 gives me 75. So I'm going to rewrite this as 5 times 5, which is 25, and we're going to put 3. We know that 25 does have a perfect square. So I'm going to split this into 2. The square root of 25 times the square root of 3. So the square root of 25 is 5. So we just write 5. And the square root of 3, well, 3 doesn't have a square root. So we're just going to write square root of 3. And that will be your answer. Nothing more than that. So in this one, we have the square root of 48. You can look at your multiplication chart and see that 48 is not a perfect square. So we need to start splitting it into smaller numbers. So we have 48. And this is an even number. So we know that we can divide this number by 2. So we have 2 times 24 gives me 48. 2 is not a perfect square. 24 is not a perfect square. Let's keep dividing. So we split this into 2 and 12. Again, 2 is not a perfect square. 12 is not a perfect square. And then we're going to split this again into 4 and 3. Now, 4 is a perfect square. 3 can no longer be reduced. That is the minimum. So what we're going to do is we're going to rewrite this. And for this problem, we have 2 different ways to approach it. So we already have the square root of 2 to the second power, because we have 2 2's. We also have 4, and we also have 3. So this is one of the approaches. What you can do in this case is split it in segments, similar to the previous problem. So the square root of 2 to the second power is 2 times the square root of 4 is 2 times the square root of 3. So now we simplify. 2 times 2 is 4. And then we cannot simplify the square root of 3. That is one way to solve this problem. The other way to solve this problem is by combining some of the terms that we already have. So we have 2 times 2 times 4 times 3. So we can multiply 2 times 2, which is 4, times 4, and that gives us 16 times 3. So if you multiply 16 times 3, you get 48. Now, you split it and you put the square root of 16 times the square root of 3. The square root of 16 is 4, and 3 doesn't have a square root, so we get the same answer. But these are 2 ways that you can approach them. You choose the method. They're exactly the same.